The Ethereum Virtual Machine. Overview. The Ethereum Virtual Machine, or EVM, is the runtime environment for smart contracts in Ethereum. It is not only sandboxed, but actually completely isolated, which means that code running inside the EVM has no access to network, file systems, or other processes. Smart contracts even have limited access to other smart contracts. Accounts. There are two kinds of accounts in Ethereum which share the same address space. External accounts that are controlled by public-private pairs, i.e. humans, and contract accounts which are controlled by the code stored together with the account. The address of the external account is determined by the public keys, while the address of the contract is determined by at the time the contract is created. It is derived from the creator address, and the number of transactions sent from that address are so-called nonce. Regardless of whether or not the account stores code, the two types are treated equally by the EVM. Every account has a persistent key value store mapping 256-bit words to 256-bit words called storage. Furthermore, every account has a balance in Ether, in way to be exact, which can be modified by sending transactions that include Ether. Transactions. A transaction is a message that is sent from one account to another, which might be the same in or a special zero account, see below. It can include binary data, its payload, or Ether. If the target account contains code, that code is executed and the payload is provided as input data. If the target account is the zero account, the account with the address 0, the transaction creates a new contract. As already mentioned, the address of that contract is not the 0 address, but an address derived from the sender and its number of transactions sent, the nonce. The payload of such a contract creation transaction 1, 2, 3. The payload of such a contract creation transaction is taken to be EVM bytecode and executed. The output of this execution is permanently stored as the code of the contract. This means that in order to create a contract, you do not send the actual code of the contract, but in fact the code that returns that code. 1, 2, 3. The output of this execution is permanently stored as the code of the contract. This means that in order to create a contract, you do not send the actual code of the contract, but in fact code that returns that code. Gas. Upon creation, each transaction is charged with a certain amount of gas, whose purpose is to limit the amount of work that is needed to execute the transaction to pay for this execution. While the EVM executes a transaction, the gas is gradually depleted according to specific rules. The gas price is a value set by the creator of the transaction who has to pay gas price times gas up front from the sending account. If some gas is left after the execution, it is refunded in the same way. If the gas is used up at any point, i.e. it is negative, or an out of gas exception is triggered, which reverts all modifications made to the state in the current call frame. Storage, memory, and the stack. Each account has a persistent memory area called storage. Storage is a key valued store that maps 256 words to 256 words. It is not possible to enumerate storage from within a contract, and it is comparatively costly to read, and even more so to modify storage. A contract can neither read nor write any storage apart from its own. The second memory area is called memory, of which a contract obtains a freshly cleared instance for each message call. Memory is linear and can be addressed at a byte level, but reads are limited to within width of 256 bits, while writes can either be 8 bits or 256 bits wide. Memory is expanded by a word 256-bit when accessing, either reading or writing, a previously untouched memory word, i.e. any offset within a word. At the time of expansion, the cost in gas must be paid. Memory is more costly the larger it grows. It scales quadratically. The EVM is not a register machine, but a stack machine. So all computations are performed on an area called the stack. It is a maximum size of 1024 elements and contains words of 256 bits. Access to the stack is limited to the top end in the following way. It is possible to copy one of the topmost 16 elements to the top of the stack, or swap the topmost elements with one of the 16 elements below it. All other operations take topmost 2 or 1 or more, depending on the operation. All other operations take the topmost 2 elements from the stack and push the results onto the stack, or it could be 2 or more, depending on the operation. Of course, it is possible to move stack elements to storage or memory, but it is not possible to just access arbitrary elements deeper in the stack without first removing the top of the stack. Instruction sets. The instruction set of the EVM is kept minimal in order to avoid incorrect implementations which could cause consequential consensus problems. All instructions operate on the basic data type of 256-bit words. The usual arithmetic, bit, logical, and comparison operations are present. Computational and unconditional jumps are possible. Furthermore, contracts can access relevant properties of the current block, like its number and timestamp. Message calls. Contracts can call other contracts or send ether to non-contract accounts by means of message calls. Message calls are simply similar to transactions in that they have a source, a target, a data payload, either gas or return data. In fact, every transaction consists of a top-level message call, which in turn can create further message calls. A contract can decide how much of its remaining gas should be sent with an inner message call and how much it wants to retain. If an out-of-gas exception happens in the inner call or other exceptions, this will be signaled by an error value put onto the stack. In this case, only the gas sent together with the call used up. In Solidity, a call contract causes a manual exception by default in such a situation, so that exceptions bubble up the call stack. As already said, the call contract, which can be the same as the caller, will receive a freshly cleared instance of memory and has access to the call payload, which will be provided in a separate area called core data. After it has finished execution, it can return data which will be stored at a location in the caller's memory, pre-allocated by the caller. Calls are limited to depths of 1024, which means that for more complex operations, loops should be preferred over recursive calls.